Hi everyone, in this video we're going to go through 6D, graphs of sine and cosine. So you're probably introduced to sine and cosine graphs in year 11. The basics that you need to know, if we're just looking at a sine graph, and we kind of went through this in an earlier video when we talked about the unit circle. So the main difference between a sine graph and a cosine graph is that a sine graph starts at 0. So you can see here it starts at 0. And if I just scroll down to look at the cosine graph, it starts at 1. So remember on your unit circle how cosine kind of represents your x variable and sine represents your y. So that's why cosine starts at 1 and sine starts at 0. Now the graphs are infinite. They keep going. Usually we have a restricted domain though. You do need to know the general solution. So we'll do that in a separate video. But usually if you're just looking at solutions, you look at solutions over a restricted domain. So in this graph here of the sine function, you can see your domain goes from negative pi here all the way up to 3 pi. So basically, we've gone through 2 full revolutions of the unit circle. So I'm going to highlight here, and this is going to make it very messy. So we've gone through half a circle, whole circle, and then another whole circle. So all up, we've gone 4 pi. So we've gone around the unit circle once, and then we've gone around it again. Okay. And you keep going around the unit circle if you need to, or you restrict it. All right, so you need to know the main difference between your sine graph. The main difference between a general solution and a restricted solution. Okay, so with your sine graph, okay, so here are the main observations of a sine graph. So we go over 2 pi, so a full revolution is just 2 pi, okay, it's a full circle. A function which repeats itself regularly is called periodic. Okay, so this keeps repeating, as I said. And so 1 period is 2 pi, 2 periods is 4 pi, and so on. Okay, so it's periodic, and it keeps going. The maximum and minimum values are 1 and negative 1. Okay, so you can see here, let me just get a different color. All right, we have a maximum of y equals 1. And a minimum of negative 1. Now that's what we refer to as your amplitude, and that can actually change, and it more than likely will. Okay, so it can go up or it can go down. All right, it doesn't have to stay between negative 1 and 1. And the same with your periods. You don't have to have the period just go from 0 to 2 pi. All right, it can go from just 0 to pi on 4. All right, it does change. So we're going to talk about that too in this video. So pretty much the same thing with the cosine graph, but we're just, you can see here, if we're starting at y equals 1, sorry, x equals 0, y equals 1, but we've still got 2 full periods, so 4 pi. We're going from negative pi to 3 pi, but you can see how it's slightly different. Okay, so your sine graph started at 0, whereas your cosine graph starts at 1, y equals 1. And so what it says here is basically the same as y equals sine x, but it's just been shifted pi on 2. And you could say in the negative direction, okay, so it can also shift in the positive direction, but it's just shifted in the negative direction pi on 2. So you can, if you were to do an equation of a trig graph, you could have it in both terms of sine or cos, okay? But yeah, it's not going to be that ambiguous, if that makes sense. All right, now I've noticed I've put this question on without actually talking about amplitude and period in too much detail. So I'm going to scroll on and then we'll come back and do question 1. All right, so your general form of a sine and a cosine graph, and they can have other transformations. So here we've got your sine graph, or your equation for the graph, and the equation for your cosine graph. So the values of a and n tell you what your amplitude and what your period are. t is just your x variable, your dependent variable. So usually we use t if it's time. Okay, so here it's t because it's representing time, but you might see x, you might see theta being used. All right, it just represents a variable, the dependent variable, the variable on the x-axis basically. All right, so I'm going to scroll here because we've just got a few examples which you can look at later. It is this box that we need to use to figure out our amplitude and our period. So our amplitude is basically just the coefficient of sine or cosine. Okay, so that is A. Your period is a little bit harder to work out. So if you can identify n, all right, so remember n is just the coefficient of t, or x if it's in terms of x. All right, that just helps us work out your period. Okay, so it's 2 pi on n. It's just not n, it's 2 pi on n. So let's go back and have a look at question 1. So we're going to do the period and amplitude. So let's see if I can do a table, might be easier. So remember, period is 2 pi on n, and your amplitude is A. All right, so if you're wondering what n and A are, remember we've got the sine equation. Whoops, got the A. Just bear with me for a sec. Okay, let's just start again. So A sine n t, and the cosine graph is A cos n t. Okay, so as long as you can identify A and n, you should be able to do your period and your amplitude. All right, so let's just do this, trying to be a little bit neater. All right, so we've got 3 sine alpha. All right, so in 3 sine alpha, A is equal to 3, n is equal to 1. So your period is 2 pi on 1, which is just 2 pi. All right, just a normal sine graph. The amplitude, however, is 3. All right, so that means instead of going from -1 to 3, sorry, -1 to 1, it goes from -3 to 3. All right, so we're just stretching the sine graph. All right, I might do the next one in a different color just so we can differentiate between the two answers. All right, so the next one is 5 sine 3 theta. It's really weird how their thetas are so small. All right, so your period, now your value of n here is 3, so we're going to have 2 pi on 3. All right, so that's your period, and your amplitude is just the coefficient of sine, which is 5. All right, so A equals 5, n is equal to 3. All right, let's do the next one. So I'll just change color so we can differentiate between the two questions. So we've got a half cos 2 theta. All right, so A is equal to a half, n is equal to 2. So your period is going to be 2 pi on 2, which is equal to pi. So that means we do one full period just in pi. Okay, so when we do sketching, I'll show you how the easiest way to sketch the graphs. Your amplitude is a half. All right, so instead of going from -1 to 1, it's going from -1/2 to 1/2. All right, we're not going to do too many because I'm sure you get the gist of it. Let's just do the next one though. Oops. Okay, so 2 sine 1/3 tiny theta. Okay, so A is equal to 2, n is equal to 1/3. Remember, n is not your period. It just helps us decide what the period is. So we've got 2 pi divided by 1/3. So that's the same as 2 pi times the reciprocal. So 2 pi times 3. So it's 6 pi. And then your amplitude is 2. Okay, so just working with a little bit of fractions there. So 2 pi divided by 1/3 is the same as 2 pi times 3 on 1, or just 3. So it's got to be 6 pi. All right, now I'm not going to go through those examples. Okay, so we've got a summary here, the period, the amplitude, the maximal domain. So a lot of the time it's restricted, but if not, it's infinite. Okay, it keeps going. And the range is restricted by your amplitude. Okay, so if we just look at this one here, the 2 cos 3t, your amplitude is 2, so we're going from -2 to 2. So your amplitude is restricted. And you can see also your domain is restricted for that one, but they can keep going forever. Do keep in mind that we're only looking at graphs with changes to the amplitude and the period. So you do need to also keep in mind that sine and cosine graphs can be shifted up or down. Okay, so remember that. They can also be translated, but that's probably taken into consideration with the period, but they can be shifted left or right or up or down. But your amplitude is basically your dilation factor, I guess. Okay, so in 6D, we're going to have to sketch a lot of graphs. Okay, so this is where it's important that you understand what the amplitude is and what your period is. Now, amplitude is probably the easier of the two. So if we're looking at question 5, our amplitude is 3. Our value of n, remember the coefficient of t is 2 pi. So that means our period is 2 pi on 2 pi, which is 1. All right, so I'm going to do the sketching down here. So we've got a bit of space. So when we're drawing our trig graphs, just make sure your variables are correct. So we're in terms of t and ft. So my horizontal axis is t, my vertical is f of t. Now I'm doing a sine graph and the amplitude is 3. So I'm going to put the amplitude on now. So going up to 3, down to -3. Now your period is 1 and you can see your domain is from 0 to 1. So what I'm going to do is put my domain on 0 to 1. And if my period was different, I would also consider that, but because my period is going from 0 to 1, I don't need to really do anything differently. Now your graph is in 4 sections, so just divide it into and then half again. Okay, so that's the easiest way to draw one period. Okay, so you've got your endpoint. So for this one, our domain is from 0 to 1, so I'm stopping there at 1. And then I divide it into 4 sections. So I halve it and then halve it again. So at this point here, I'm at a half. This is at 1/4, and this is 3/4. Now, I'm going to draw it in a different color. So it was a sine graph from memory. Sine. Okay, so a sine graph, remember, starts at 0. Then goes up, reaches its highest point here at 1/4. And then it goes down to here, and then it goes, crosses the t-axis, goes down to here, and then goes back up. So the shape of your sine graph is always the same. It's just your scale that's really changing. So it's important that you get your scale correct, but as long as you can split it into 4 equal parts and, plot your points and then join your points. So remember, it is a sine graph, so it's got to be nice and curved. It's a bit harder to do on the computer. But that's pretty good. All right, so there's your sine graph. So getting your scales correct. The shape is usually always the same. All right, so getting your scale correct first and then just, joining the dots. All right, let's have a look at question 6. So for this one, we have an amplitude of 3, a value of n, so the coefficient of t is pi on 2. So that means your period is equal to 2 pi on 2, which is equal to 2 pi times 2 on pi. Okay, so instead of dividing by pi on 2, we multiply by its reciprocal. So the pi's are going to cancel out. So then we've got 2 times 2, which is 4. All right, so let's sketch our graph. So very similar to before. We've got t and f of t. We've got the same amplitude. So from 3 to -3. This time, we're only going from 0 to 1. So notice that our period is 4. Okay, so I'm going to still go ahead and separate it into 4 parts. So 1, 2, 3, 4. But we only want from 0 to 1. So if I'm sketching that, remember it's a sine graph. So there's our first point. So that's the only section we want, from 0 to 1. Now, it was probably a bit unnecessary to do the whole scale because we really wanted that part, which I didn't realize until I started drawing it. But if we were to keep going, and I might just dot it because it's not really a part of the question, it would look like that. Oops, kind of like that, sorry. My turning point should have been at 3. So you can see how the shape of it, of question 5 and 6, they're the same shape because they're sine graphs. It's just the scale that changes depending on what your period is and depending on what your amplitude is. So for question 5 and 6, the amplitudes were the same, but the periods were different. All right, let's have a look at question 7. Scroll down, sorry. Okay, so it's given us a restricted domain here. So we're going from 0 to pi. Our amplitude is 5. Our value of n, so the coefficient of x is 3. So your period is 2 pi on 3. But we only want to go from 0 to pi. All right, so let's have, this one's going to be a hard one. All right, especially because I have to keep scrolling. A little bit annoying. Okay, and what were our variables? X and f of x. All right, so our amplitude was from 5, so -5, and we only wanted to go from 0 to pi, but our period is 2 pi on 3. So let's do our period first. Now remember we need to split that into 4 equal parts. Okay, so 2 pi on 3, half of that is going to be 2, I know it's going to be 2 pi on 6, but 2 pi on 3 divided by 2. Okay, so we want half of it, so it's the same as 2 pi on 3 times a half. So it's going to be 2 pi on 6, which is the same as pi on 3. All right, and then if you want half of pi on 3, it's going to be pi on 6. And then, so that's 2 pi on 6, and this should be pi on 2. So 1 pi on 6, 2 pi on 6, 3 pi on 6, 4 pi on 6. Now we only want to go to pi. Oh, that's a bit annoying. So pi, we've got to keep going. We're not actually quite there. Sorry, we've only done one period. So let's just extend the graph a little bit. So you can see each time I'm going up by pi on 6. So the next one, so we've got 1 pi on 6, 2 pi on 6, 3 pi on 6, 4 pi on 6, 5 pi on 6, and then we've got pi. All right, so if you can work out the scale, then you can keep going. All right, so this one, probably the hardest one we've encountered so far. All right, so I can't remember what sort of graph it was now. It's a cos graph. All right, so remember your cos graph starts up the top, Okay, and then we're going down like that. Then it's got a turning point at the next point and then comes back up here. All right, and then it's got a turning point above. Oh, it's probably not that high. So we're going to go around like that. And then we want to stop at pi, so we keep going and we stop there. All right, let's keep going because these can be quite tricky. So maybe if you wanted to, you can pause and then watch the rest if you need to. Remember, these questions are taken from your textbook, so you don't need to watch them to get the answers. So your amplitude is 1/2. Your value of n is 2. So your period is 2 pi on 2, which is just pi. All right, so we're doing question 8. Just double check that I've written everything correctly. This time we're going from negative pi to 2 pi. All right, so when I sketch my axes, I need to take that into consideration. All right, so I'm going to go down here. So, sorry, I'm going to have to keep shifting, actually. If I actually just write the function, then I can 1/2 sine 2x. And we're going from negative pi to 2 pi. Okay, so I know I have to go in the negative x, so I'm going to just draw it a bit bigger this time. And then we've got y and x. I can't remember whether it was f of x or y, but it doesn't matter. All right, so our amplitude is 1/2. So we're going to have 1/2, negative 1/2. And our period, oh my God, what was it, pi? Now I just realized that I probably should have that one a little bit longer because we're going to negative pi. All right, so divide it into 4. So we've got pi on 2, pi on 4, 3 pi on 4. So effectively going up by 1/4 each time. If it helps, I'm doing it with in simplest form, simplest fractions. If it is too difficult, just have the same denominator. So you could have pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4. All right, might help you do your scale a little bit easier. Now, if we're going back this way in the negative x, so I'm going to have negative pi on 4, negative pi on 2, negative 3 pi on 4, and then negative pi. All right, now let's get a different colored pen. Oh, I had to go to 2 pi. Oops. Oh, just got rid of my whole axis. It's all right. Draw it again. I was wondering why I had such a long axis on this side, and that was why, because I wanted to keep going. There we go. All right, so let's just keep going to, so then we're going to have, remember going up by 1/4, so we're going to have 5 pi on 4, 6 pi on 4, which is the same as 3 pi on 2, 7 pi on 4, and then 8 pi on 4, which is 2 pi. Okay, so again, if you don't want to have, if you're not confident with different denominators, put them all over 4, okay, and then just simplify them later. All right, so we're a sine graph, so we're going to start here at 0, and then we go up, and then down, and then down, and then up, and then up, whoops, too high, down, down, and we're stopping at 2 pi, because remember that was our domain. And then let's go in the negative direction, so we're going to go down and up, then down. And then we just join our dots, so you choose where you want to start. Oh, not the most accurate, but you get the gist. It's a long one. All right, so the hardest part, I think, for drawing cosine and sine graphs is getting your scale correct and your period correct and making sure you're in the right domain, so the restricted domain. All right, let's keep going. So question 9. So remember, you can pause at any time and do these questions on your own. Don't expect me to do them all, but you're more than welcome to watch. All right, so 2 cos 3x on 2. And I didn't take note of our restricted domain, so that's probably good. I just go back up and check. So 0 to 2 pi. Okay, so our amplitude is 2. Our value of n, remember the coefficient of x is 3 on 2, so that means our period is equal to 2 pi on 3 on 2, which is the same as 2 pi times 2 on 3, which is 2 times 2 is 4, so 4 pi on 3. All right, so a bit of a tricky one to draw. We're going from 0 to 2 pi. So get my axis, that's a bit bigger than what I probably would have expected. All right, so we've got x, and here we've got f of x. Our amplitude, so we're going from 2 to -2. Whoops, don't know why I was about to write 3. Okay, so our period is at 4 pi on 3, and we're going all the way up to 2 pi. So I'm going to just put 4 pi on 3 here. All right, so halve that is going to be 4 pi on 6. All right, and then halving that again is going to be 4 pi on 12. And then here, halfway, so when you, let me just simplify it a bit. So we've got 3 pi, pi on 3, 2 pi on 3, 3 pi on 3, so we've got pi here. So we're going up by 1/3 each time. 4 pi on 3, 5 pi on 3, 6 pi on 3, and I know I need to stop there. So just with it can be quite difficult with fractions, and in methods, sometimes, the hardest things are a lot easier than fractions. So when you're doing your period, so we know our period is 4 pi on 3, which I've got written here. Halving that, I basically just double my denominator. So I knew it was going to be 4 pi on 6. And remember, 4 pi on 6 is the same as 2 pi on 3. Okay, so if I was to write that in simplest form, it's the same as 2 pi on 3. 4 pi on 12 is the same as pi on 3. And then you can see that I'm going up by pi on 3 each time. So 1 pi on 3, 2 pi on 3, 3 pi on 3, which is the same as pi. 4 pi on 3, 5 pi on 3, 6 pi on 3, which is the same as 2 pi. All right, let's sketch our graph. So we've got a cos graph. So we're starting here up at 2, crossing the axes here, going down, then back up. Okay, so remember your shape is the same. It's just your scale that changes. So until we get into transformations, you should be able to draw these graphs. All right, there we go. That's a bit wonky, but it's question 9. I might not be able to do them all. What's the next one? Okay, we haven't had a negative graph. That's all good. Okay, so what do we got? -3 cos x on 2. And just double check everything, and I need the domain. 0 to 4 pi. Oh, it's going to be a long one. Okay, so our amplitude is 3. Okay, it doesn't matter that it says -3. Your amplitude is still the positive value. Your value of n is half. So your period is 2 pi and a half, which actually makes that 4 pi. So that's quite not as hard as I thought it was going to be. Okay, so let's quickly draw that. We've got x, we've got y, put your amplitude in 3 and -3, and then we're going all the way up to 4 pi, which doesn't make any difference. You can, what am I doing? 2 pi, pi, and 3 pi. So a nice easy one. So if the negative sign, if you think about it, I'll give you a sec to think, what do you think that negative is doing? It's just reflecting our cos graph. So instead of starting at 3, we're starting at -3. Okay, so we go up 2 pi, 3 pi, 4 pi. Okay, so it doesn't matter that it's a negative. All right, so there's our cosine graph. All right, question 11 and 12, I've noticed they've got some transformations. So let's have a look at them. I don't want to skip them. So find the equation of the image of the graph y equals sine x under the dilation of factor 2 from the x-axis, followed by a dilation of 3 from the y-axis. All right, so with the dilation factor from the x-axis refers to our amplitude. So let me just... Okay, so that is our amplitude. And then dilation from our y-axis refers to your period. All right, so just like before, the amplitude was a lot easier to do. So let's do that first. So your amplitude, if we've dilated it by a factor of 2, it's stretched it out by 2. So we're going to have A equals 2, and we'll do the equation in a second. And I'm sorry to squish everything in here. But if we've dilated from the y-axis, our period is going to go from 2 pi times, so originally 2 pi, and we're dilating it by a factor of 3. So we're going to multiply it by 3, so it becomes 6 pi. So you've got to kind of think, well, what is my value of n? Okay, so if we want it to go from 2 pi to 6 pi, so we're stretching it from the y-axis, what is n equal to? So to work out your period, I might just do this over here. So remember, your period is equal to 2 pi on n. Now, the period for this one, because we know that it's been dilated by a factor of 3, so 2 pi on n has to equal 6 pi. So in order for it to equal 6 pi, let's just solve the equation. So n is equal to 1/3. All right, so your dilation factor from the y-axis, it's not 3, it's the reciprocal, so 1 on 3. So for question 11, oh, I don't have any space. Might just write it up here. So question 11, we've got a sine graph, so it's going to be y equals, your amplitude is 2, sine, and then we've got to think of your your value of n. The coefficient of x is 1/3, so 1/3 x, which we tend to write as x on 3. So if you wanted to test it, you can always, work out what your period is. So remember, if we're dilating from the y-axis, we're changing the period. If we're dilating it from 2 pi, and we're dilating it by a factor of 3, so 2 pi times 3 gives us 6 pi, you've got to think, well, what is my value of n going to be then? All right, so let's have a look at question 12. So we've got half from the x-axis, and we've got a same dilation factor, which is a bit annoying because it'd be nice to have something different. All right, I might write this question in green. So we've got y equals, your amplitude is a half, so half cos, and then your value of n. So we did 3 before, so it's going to be 1 on 3, so it's just going to be x on 3. If it was dilated by a factor of 2, it would be x on 2. Okay, so just think of this, what we did here, to work out your value of n. All right, and I think that's our last question, and we might end the video here. Let me just check. All right, so then we move into 16. All right, bye girls.